Our second subtopic is graph of simple harmonic motion, and we are going to discuss 4 types of graph. The first one is graph of displacement time or xt graph. From the equation, x is equal to a sine omega t, mean our graph is from in the function of sine, and from this graph we can find out the maximum displacement, which is the amplitude a or negative a, and also the period for the oscillation. The second graph is graph of velocity time or vt graph, and v is equal to a omega cos omega t, and from this graph we can find out what is the v maximum, a omega, and also period for the oscillation. And then the next graph is graph of acceleration time or at graph. From the equation, a is equal to negative a omega squared sine omega t, and from this graph we can find out what is the maximum acceleration, a omega squared, and also period of the oscillation. The next graph is graph of energy displacement or EX graph. And from this graph, we can find out the total energy, potential energy, and kinetic energy. For kinetic energy graph, is referring to this blue graph. And from this kinetic energy graph, we can find out that at equilibrium position, the kinetic energy is maximum, but at amplitude, kinetic energy is equal to 0. And for this brown graph referring to the potential energy graph. Potential energy graph showing that at equilibrium position, potential energy is equal to 0, but at amplitude, the potential energy is maximum. And for the total energy graph, E is equal to half m omega squared A squared. It's showing that the combination for kinetic energy and potential energy at any position in the graph. Figure shows the displacement of an oscillating object of mass 1.30 kg varying with time. The energy of the oscillating object consists the kinetic and potential energies. And we are going to calculate the angular frequency of the oscillation and the sum of these two energy. And now we have a graph of x against t, displacement time graph. And then from this graph, we can find out the amplitude, means the amplitude is equal to 0.2 meter A, and the period is equal to 4 seconds. And then from this information, we can calculate the angular frequency, which is omega is equal to 2 pi over t. Means 2 pi over 4. And then our omega is equal to pi over 2 radian per second. Now we look at to the second question, the sum of these two energies. The sum of the energies means the total energy between kinetic and potential energy. And then the equation for the total energy is equal to E is equal to 1 over 2 m omega squared A squared is equal to 1 over 2, 1.30 omega is pi over 2 squared, and A is 0.2 square. And you will get the answer here is 6.42 times 10 to the power of negative 2 joule. The last subtopic is period of simple harmonic motion. In this subtopic, we can calculate the period T for a simple pendulum and also for a single spring. This is how to calculate the period for a simple pendulum oscillation, which is we can use this equation. T is equal to 2 pi sert L over G. T is referring to the period of simple pendulum, L is the length of the string, and G is the gravitational acceleration. But you should obey this condition. The first one is the angle has to be small, means less than 10 degree. The string has to be inelastic and light. And the last one is only the gravitational force and tension in the string acting on the simple pendulum. And the next one is period for single spring oscillation. We can use this equation. T is equal to 2 pi sub m over k, which is T is period of spring oscillation, m is mass of the object, and k is spring constant. But it should obey this condition for a spring mass system, which is the elastic limit of the spring is not exceeded when the spring is being pulled. The spring is light and obey Hooke's law. And the last one is no air resistance and surface friction for the single spring oscillation. The length of a simple pendulum is 75.0 centimeter, and it's released at an angle 8 degree to the vertical, and we are going to calculate the period of the oscillation. So here I just figure out the situation for this pendulum. We have 8 angle 8 degree with length L. So we take out all the information given, means L is equal to 75.0 cm, so we can convert to meter, means 0.75 meter, and our theta is 8 degree. The next one, we are going to calculate the period of the oscillation. So for a simple pendulum, to calculate the period means we use the equation T is equal to 2 pi sub L over G. This L was referring to the length of the pendulum. Okay, so now we just substitute 2 pi sub, our L is 0.75 over 9.81, and then we will get the answer, which is 1.74 second. The second question is we are going to calculate the speed and acceleration when it passes through the lowest point of the swing. The lowest point means the equilibrium position O. So here, to calculate the bob speed and acceleration, so we know that at the lowest point, V is maximum. V maximum, because kinetic energy maximum at the lowest point or at equilibrium position. So we are going to use this equation. V max is equal to A omega. So now we are going to calculate the A, amplitude for the oscillation. The amplitude means the displacement from equilibrium position to point A. This is the amplitude. Alright, so now based on this triangle, we have L and also we have theta. So means we use sine, function of sine. So sine theta is equal to opposition A over hypotenuse L. So here we will get that A is equal to L sine 8 degree. L sine 8 degree times with the omega, and then our omega is 2 pi over T. So we just substitute L with 0.75 sine 8 degree and 2 pi over T. Our period is 1.74. And then we will get the answer V max is equal to 0.378 meter per second. At equilibrium position, A is equal to 0 ms to the power of -2.